So my name is Zhang. My research interest is algorithm foundation of big data. So today I will introduce one of my research direction, communication efficient distributed computation. So big data is often collected and stored in different locations, but we still want to answer queries that are on the global data sets. So the coordinate model is a very popular model that is proposed for this type of computation, where we have S machines and one central coordinator. The data is stored across the machines, and the coordinator want to output the final answer. So the computation is in terms of rounds. At the beginning of each round, the coordinator send a message to each of the machines, and they reply the message back to the coordinator. So our goal is to minimize the total bits of communication and the number of communication rounds, because those items are those major items that will contribute to your data, energy, time bills. Okay, so I study fundamental problems in a number of areas: database, data mining, machine learning, and bioinformatics. So today I will give you two examples. The first is string similarity join, and second is clustering. Okay, so the string similarity join the problem is like this. So the input is just a set of strings. They are stored across those machines, and we want to find all those pairs that are similar. Similar means their added distance is at the most k. K is some parameter. Okay? So one way to do this is that each machine, for each string, just compute a summary or sketch and send it to the coordinator. And then given two sketches of two strings, the coordinator can determine whether the distance is at most k or not. Okay, so here the communication is just one run, and the total bits of communication is just this number of strings times the sketch size of each string. Okay, so with my collaborator, we proposed a sketch, the first sketch of sublinear size, and this solves a major open question in the area of sketching algorithm, and our technique makes use of some random walking embeddings. But this one sorry. Seems don't work. Okay, yeah, it's fine. Yeah. Sorry. So, but this result still not very practical, because when k is slightly larger, k to the power 8 is very large. So then later with my PhD student Zhang, so we proposed a more practical algorithm, and our algorithm beats all the previous algorithms in order of magnitudes, even in a RAM model. So the next problem is the clustering with outliers. So again, we have a set of points, and they are stored distributed across the S machines. Our goal is to compute the standard object function k means, k median, k center, with also allow some outliers across the union of the data. So with my collaborator, we proposed the first theoretical optimal, first algorithm with theoretical optimal communication cost, and it used the 2 rounds. And this paper got best paper award recently in SPA 2017. And later with my students, we proposed a more practical algorithm, and this algorithm is 1 round, so this is why it's even more practical than the one we had before. And this, in practice, this beats all the previous algorithms in our metrics. So that's it. Thank you.